Hi everyone, welcome back to my channel. There's a lot of buzz in the AI industry these days about Gen AI or generative AI, especially around the popular models like ChatGPT, DALL-E, Gemini, Midjourney, and others. All this must be sounding similar and exciting at the same time. But before understanding all this, let's understand what exactly generative AI is in simple terms. Before we dive into this world of generative AI, let's take a moment to understand its evolution first of all. Generative AI represents the latest innovation in the long journey of AI data representations. But this journey started way back in 1980s. The 1980s started with expert systems. So expert systems marked the early adoption of AI. These were rule-based systems designed to solve business problems. However, they relied on large complex sets of logic, which were tedious to maintain and debug at the same time. While innovative at the time, they are not considered true AI by today's standards at all. And you know the reasons why, because obviously they were like for loops, they were having conditional statements. Obviously they were not having any capability to learn the data's the learn from certain examples on its own, right? It were like script oriented informations or data are provided there. In the 1990s, machine learning came into play. The 1990s introduced machine learning models which required large amounts of label training data. These models were effective for specific tasks, but were expensive to train and not easily transferable as well. Despite the challenges, ML continues to be widely used due to its powerful capabilities in the industries. The pre-2010s saw the early adoption of deep learning. So this particular term deep learning is a subset of ML, which focuses on the deep artificial neural networks. Before 2010, deep learning research was limited because even shallow neural networks were extensively compute intensive, right? It required huge amount of compute power. This changed with the convergence of three key factors. Those are availability of massive label datasets, inventions of new deep learning algorithms, and lastly, more affordable and powerful CPUs and GPUs. Now comes the era of 2020s, the rise of generative AI, so called. The early 2020s brought about the new leap in the AI modeling. Generative AI came into existence. Unlike the traditional ML models, generative AI is trained on massive unlabeled datasets using self-supervised learning. These models are pre-trained and are ready for consumers' use, leading to their massive success. The fourth generation of AI, the era of generative AI. We are now at the beginning of what many call the fourth generation of AI, known as the era of generative AI, as I mentioned before. The new phase promises to revolutionize the AI landscape with models like ChatGPT, DALL-E, Gemini, Midjourney, and many more that we'll talk about in the upcoming videos. Now, coming next to what exactly is generative AI. So generative AI is a branch of artificial intelligence that focuses on creating models capable of producing new content. These models learn patterns and structures from training data and use this knowledge to generate new data such as text. It can be images, musics, or other media-oriented informations as well. The primary goal of generative AI is to create outputs that are indistinguishable from those created by humans. You can define it in two types. One can be generative image model, and the second one is generative language model. Let's understand both these terms in a bit of depth in the next slide. So, generative image model is a type of artificial intelligence that is designed to create new synthetic images that resemble a real image, which you can see anywhere, right? These models learn from a dataset of existing image and generate new images that share similar characteristics and patterns. Generative image models can produce realistic or synthesized or stylized images based on the learned data, enabling the applications in various fields such as design, entertainment, and even medical imaging. You can see the two images on this particular slide. The left one is a mid-journey Gen AI model where using simple prompts or text, you can create AI generated images very easily. Similarly, on the right hand side, you can see that the creative images can be generated on DALL-E using simple natural languages or prompts as well. So that's how interesting the entire model landscape is. Now coming to the generative text model. A generative text model is a type of artificial intelligence which is designed to create coherent and contextually relevant text based on patterns learned from large data of existing text. Okay. So this particular models can generate human-like text by predicting and by stringing together words, you can say sentences or even entire documents very easily. Generative text models are widely used in various applications such as content creation. It can be used in chatbots. You will see its utilization in the language translation particular sector as well. And you will see a lot of utilization of the generative text model in the summarization industry as well. The most famous of its OpenAI founded ChatGPT, right? So one of the most famous models is ChatGPT, and now there are different versions like 2, 3, 4. I don't even know. I mean, might be by the time I'm creating a new video right now, even ChatGPT might have released a new one. So, I mean, sky's the limit for generative text models as well, and that's how LLMs came into existence. Okay, I'm getting distracted. We'll talk about LLMs in some another video, so stay tuned for that as well. So basically, on the screen you can see on the left hand side that a simple prompt or a text is provided to the model, uh, simply by asking, let's say, how to create my own generative AI model. And over here in the prompt section, you can see I have also mentioned or requested the model to keep the answer pretty precise. On the right hand side, now you will see that the text generated response of the model is visible, right? It provides step-by-step instructions in order to achieve it. So that's the kind of capabilities this generative models hold. Okay. So as I told you, the sky is the limit for even generative text models. The industry has just begun and there are a lot of many innovations and inventions coming in the near future. So I'm always excited about it. And I'm pretty sure you guys are always excited as well. So let's move on to a couple of more terminologies or certain, uh, I'll say, industry oriented keywords that you will see or hear a lot of times if you become a data scientist or a gen AI engineer. You never know. So let's hear about couple of them. So let's understand about homogeneous and heterogeneous model. Basically, what's the difference between them and what exactly are these terms? So homogeneous and heterogeneous AI models refer to system comprising either uniform or diverse types of models respectively. Okay. Let's begin with homogeneous AI models. Don't take any sort of tension. I'll keep it pretty crisp and simplified as well. Okay, just bear with me and stay with me on this particular topic. I'll explain you exactly what it is. So a homogeneous AI model consists of multiple instances of same type of model, often which are trained on similar data or performing similar task. Okay, and these models are uniform in structure and functions. When we talk about uniform architecture, uh, in this particular homogeneous AI model, all models have the same architecture and design. They also have similar training data, okay, because they are trained on the similar sort of informations at any given point in time. In terms of consistency, they offer consistent performance and behavior across different instances very easily. They can also be deployed in parallel to improve performance or handle large volumes of data. In terms of ease of management, it is pretty easy to manage and scale due to its uniformity. Okay. In such models, you can see in this particular slide that, let's say, if the input is a text, then the output generated by the generative AI model will also be a text. You can see the uniformity in terms of text as well, right? Similarly, on the other hand, if the input will be an image, then the output will be an image as well. So you can see the uniformity. You will not see that if the input is text, then the output will be a image, right? Then it will corrupt the uniformity, right? It will not be uniform anymore. So the input has to be similar to the output. That's what homogeneity means, right? Whether if it's a text, it should be output should be a text, and if it's an image, the output should be an image. Let's move on to heterogeneous model now. So a heterogeneous AI model, on the other hand, involves a combination of different types of model, right? As the term suggests itself, heterogeneity means difference, okay? And each specialized uh, for different tasks or different types in general, right? These models are diverse in structures and functions as well, and are often integrated to complement each other very easily. Okay. If I talk about the heterogeneous AI models architecture, then basically they are models with different architectures and designs. In terms of training, they are trained on different types of data specific to their function. Okay. Depending upon their functionality and their usefulness, they are trained on different sort of informations or datas. In terms of specialization, each model is specialized for a particular task or a data type itself. Okay. And lastly, if we talk about the complementarity, how exactly it can complement each other, then these models work together to leverage their individual strengths, and that's how they attain the end goal. For example, let's say if the input is a text, then the output will be an image. It cannot be uniform. It cannot be as if the input is text, then just like homogeneity, you will not see the output being in text over here, obviously, right? So it has to be different. And they have different training programs for different parts of this architecture. Okay. In simple words, if I have to explain, then if the input is text, then the output will be an image. And let's say if the input is an image, then the output will be a text, right? Like vice versa. Just understand this basic terminologies. If we have to understand all these topics in depth, I think in upcoming videos you'll start understanding all these terminologies and exactly how the particular architecture works and everything. So stay tuned with me for all those things. But for the timing, if you are fresh into Gen AI, then this terminologies and this understanding is enough to begin with your journey of Gen AI. Lastly, I'll talk about exactly what is discriminative versus generative AI models, right? So basically, when we talk about discriminative models or classical models, they are basically into focusing on recognizing and classifying things very easily. Example of a discriminative model can be, let's say, telling whether an email is a spam or not. Okay, and if I talk about the working, then then basically by looking at the data and learning the difference between the category is what it does. Okay, and the use case example for particular this particular discriminative model is seen on this particular slide on the left hand side. If you see, you'll see like the example where on the training or the input end, different images or training data of cats and dogs are given. Okay, and the model is tasked, or its goal is to distinguish or classify the different images into two categories. Let's say if whether it's a cat or whether the image is of that of a dog. So it's that simple. Okay. On the right hand side, now I'll talk about the generative models. Basically, similarly, if I have to explain generative AI models, then I will say that what they do is to focus on creating new data. The example of this particular generative AI model can be like generating a new or a realistic looking photo of a cat, dog, or any other animal very easily. Okay. And how do they work? They work by learning to understand and replicate the entire data set. So basically, they engulf and they understand the features of the training data sets, and that's how they train their entire algorithm. They train themselves so that on the output end they can create something unique or something creative, something which is not present in the uh, training data exactly. If I have to explain, okay, they create something that they learn from the training data, and then they project something unique that they have created on its own. So when I say they, I mean the generative AI model in this particular scenario. Okay, I hope all these concepts were very easy to understand. And lastly, if I have to just give you the main differentiating factors, then you can just remember a couple of keywords. In terms of discriminative modeling, you remember just one thing, that is it classifies and sorts the existing data. Okay, sorting and classification can be on any vertical. Okay, depending upon the example, like let's say this particular example over here, let's say classifying or sorting out two different categories, one for cats and another for a dog family, right? Similarly, on the generative end, if you see on the left hand side, uh, in again in simple words, it creates new or similar data. Similar, why am I saying? Because let's say if the training data you are feeding of something like cats and dogs, and then you ask the model to generate another creative image of a dog, then obviously it will be similar to the training informations in terms of the feature capabilities. Obviously, it will learn the features from the training data, and then it will be able to project the resultant on the I'll say on the end goal, or the on the end resultant part, right? So that's it. Uh, Thank you guys. I'll meet you guys in the next video. Till then, keep reimagining data with AI. That's what I like to say always. And thank you all. Like, subscribe the channel as well for more interesting videos and stay tuned. Okay. Have a great day. Bye bye.